Hello friends, continuing with the topic of junction diode in electronic devices. Today we come to its next part, IV characteristics. Today's topic is IV characteristics of a semiconductor diode. So what is the definition of IV characteristics? Let us define the curves showing relationship between current flowing through the diode and voltage applied across the diode are known as IV characteristics of the diode or current voltage characteristics of the diode. I repeat the definition. The curves showing relationship between current flowing through and voltage applied across the diode are known as IV characteristics of the diode. Now we have two characteristics of the diode, forward characteristics and reverse characteristics. So first we take up forward characteristics of the diode. Now what is definition of forward characteristics? Let us define. The curves showing relationship between current flowing through and forward bias applied across the diode are known as forward characteristics of the diode. I repeat the definition of forward characteristics. The curves showing relationship between current flowing through the diode and forward bias applied across the diode are known as forward characteristics of the diode. Now, second part of forward characteristics, how to plot forward characteristics in laboratory. First we need circuit diagram. So this is the circuit diagram which is required for plotting IV characteristics of the diode in forward bias conditions. Now this is rheostat which controls the forward bias. This is battery, this is key, this is voltmeter, this is milliampere meter, and this is the diode. Okay, you take all these components and proceed step by step. First step is arrange the circuit as shown. In the next step, you close key K. After closing key K, the circuit will become active. Third step, record values of current in milliampere meter for various values of forward bias V, which can be recorded from voltmeter V by adjusting a rheostat in a table format as shown. So you plot these values for different forward bias like this, and in the fourth step you plot VI graph, which would come out to be as shown. This is for germanium junction diode and this is for silicon junction diode. Now here you note these 2 points. This is the barrier voltage for germanium diode and this is the barrier voltage for silicon diode. For germanium it is 0.3 volt and for silicon it is 0.7 volt. Now forward characteristics for germanium and silicon diodes are found to be as shown here. Okay. Now we come to dynamic resistance of the diode. Now what is dynamic resistance of the diode? Let us define. Slope of IV characteristics of the diode is defined as dynamic resistance of the diode. I repeat, slope of IV characteristics of the diode under forward bias conditions is defined as dynamic resistance of the diode, mathematically expressed as Rd is equal to dV by di. Of course, SI unit is ohm. Now look at this graph, that is IV characteristics of a junction diode. Take any 2 points, this point and this point. Draw perpendicular from these points on x-axis and also draw perpendicular from this point to this point, and then calculate dV and then di. Then we will substitute in this formula Rd is equal to dV by di, and we will have the dynamic resistance of the diode under forward bias conditions. Okay. Now assignment 14 continued. Question number 25. Give the values of threshold voltage of germanium and silicon diodes. Of course, it is for germanium 0.3 volt and for silicon it is 0.7 volt. Question number 26. Define dynamic resistance of the diode. Now we come to reverse characteristics of semiconductor diode. Now what are reverse characteristics? Let us define first. The curves showing relationship between current flowing through and reverse bias applied across the diode are known as reverse characteristics of the diode. I repeat the definition. The curves showing relationship between current flowing through the diode and reverse bias applied across the diode are known as reverse characteristics of the diode. Now second point, how to plot reverse characteristics in laboratory. Let us proceed step by step. First step, arrange the circuit as shown. The circuit is same with the difference that diode has been reversed. Previously a node was on this side and now a node is on this side. You look at the difference between the circuit, the connections of diode have been reversed. Second step, close key K. Third step, record values of current in microampere meter for various values of reverse bias, which can be recorded from voltmeter V by adjusting a rheostat in a table format as shown. Like this, you record values of microamperes for various values of reverse bias like this and fill up the table. Fourth, plot I versus V graph. So the I versus V graph comes out to be as shown in diagram here. So reverse characteristics for germanium and silicon diodes are found to be as shown above. Now what IV characteristics suggest? Now look at forward characteristics of the diode. This is forward bias and this is forward current, and characteristics is as shown. Now here we apply AC input and this side we get output. Now we see that only positive halves are available at the output and negative halves are absent in the output. So it means in the output half cycles are available at the output when we apply AC input to the diode. So when positive half is coming, diode is conducting and we are getting output. When negative halves are coming, diode is not conducting and we don't get negative halves at the output. When positive halves are applied at the input, then diode becomes under forward bias conditions and conducts. So we get positive halves. When negative halves are applied at the input, the diode becomes under reverse bias conditions. So diode does not conduct, so we don't get any current at the output. Okay. So this way, forward characteristics suggest that the diode can be used as rectifier, can be used as switch, can be used as a gate, can be used as peak caliper, can be used as power protector, and also can be used as radio detector. Here we are to study use of diode as rectifier only and not other applications. Okay. Z-band 14 continued. Question number 28. What are IV characteristics? Define forward characteristic of a PN junction diode and draw it. Question number 29. A part. Draw the circuit diagrams of a PN junction diode in forward bias and reverse bias. How are these circuits used to study the VI characteristics of a silicon diode? Draw the typical VI characteristics of silicon diode. Question number 30, part 1. With the help of circuit diagram, distinguish between forward biasing and reverse biasing of a PN junction diode. Second, draw the characteristic of a PN junction diode in forward bias and reverse bias conditions. Question number 31. How does the width of depletion layer of a PN junction diode change with decrease in reverse bias? Okay. Thank you so much. Next time we'll take up application of diode as rectifier. So we are going to study rectifier in the next lesson. Till then, goodbye and good luck to you.